Today we are going to use ratio tables to organize and write our equivalent ratios. So here's a couple of examples of ratio tables. There are different structures we can use to complete them, and really we're just finding patterns. So you potentially have seen ratio tables before. Maybe you were told to find the pattern, fill in the missing blanks, but the actual vocab word ratio table will be new. So if you look at this first example, we have one triangle, three sides. We know a triangle has three sides. How many sides would two triangles have then? That would be 6. But if we didn't know that, if we look at the pattern, we're trying to fill in this blank here, and we can see to get from 1 to 2, that's 1 times 2, so I'm going to do 3 times 2. So we would get 6. Then we move on to the next blank here. Okay, so I'm going to go back to the beginning and do 3 times 3 gives me 9. So 1 times 3 gets me here. And then when we get to this blank, we have some options. We can go down here and go 2 times 2 and 6 times 2, or go back to the beginning again, 1 times 4, 3 times 4. Okay, and that's what we call our multiplicative structure. Sometimes the multiplicative structure works across the ratio as well. For example, 1 times 3, 2 times 3, 3 times 3, and 4 times 3. And then we have what's called the additive structure, where in this example you can see you're adding 1, 2, 3, 4. You're adding 1 every time. And then here you're adding 3 every time. 3, 6, 9, 12. Okay. The additive structure does always work, but it's not always very efficient. So if you look at this next one, we have frogs and toads, 4 to 6. So filling in this blank, we didn't just add 4 and we didn't just add 6. And we could keep adding 6 to get to the 180, but that would not be the most efficient way to solve this. So we're going to use that multiplicative structure again. And I'm going to look, 4 times 5 is 20, so 6 times 5 is 30. And then again, I'm just going to start that pattern over. 30 times 3 is 90. So we're going to do 20 times 3 to get this. Okay, and then here, 90 to 180, I'm doubling that. So I'm going to double this and get 120. Then the additional piece here, it says to write the equivalent ratios. So what we're doing is just now proving that all the ratios we just created are equivalent. So triangles to sides, we have 1 to 3, 2 to 6, 3 to 9, 4 to 12. Those are our 4 equivalent ratios. Over here, we have 4 to 6, 20 to 30, 60 to 90, and 120 to 180. Go ahead and pause your video and try 1 and 2 down here. Fill in the blanks and then write your equivalent ratios. All right, and you can check your work here. All right, now we're going to go ahead and flip this over. Okay, and then this time we're going to make some comparisons. So it says you make red food coloring from beets and blue food coloring from cabbage. And to make colored frosting, you add 3 drops of red food coloring for every 1 drop of blue food coloring. Your friend adds 5 drops of red for every 3 drops of blue. Ultimately, what we're trying to answer is whose frosting is redder. So a little bit of an art lesson here. If it's blue and red, our frosting should look kind of purple. So let's go ahead and fill in the tables first. So go ahead, this is your frosting, this is your friend's, and we know you put in 3 drops of red and 1 drop of blue, so that's 4 drops total. Here's your friend's ratio and their total. So go ahead, pause, and take a minute to fill in the table. And then when we look at this, I just use the additive structure the whole time, adding another drop of blue each time, 3 more drops of blue each time over here, and then getting the total. But we could also use multiplicative because 3 times 2 is 6, and then do 1 times 2, and then 1 times 3, and 1 times 4. 5 times 2 is 10, so this is 3 times 2, 3 times 3, and so on. So now we're just going to make a comparison. If we want to see whose is redder, we can look at that, but really we can look at the actual ratio or recipe and see which one is going to have more actual red dye in the frosting. So in order to do that, we have to find something that's the same. So for example, if we compare the drops of red and the drops of red here, okay, we can see that at some point We both put in 15 drops of red. So if we compare that, when I put in 15 drops of red, I put in 5 drops of blue. When my friend put in 15 drops of red, they put in 9 drops of blue. So theirs is actually bluer. Okay? So that's one way we can compare. We can also look at the total. So we can see at one point we both had 8 for our total. And we also both had 16 for our total. So when we look at that, when I had 8 total drops, I had 6 drops of red, and my friend had 5, so I had more red. Okay, when I put in 16 drops total, I had 12 drops of red. My friend had 10, so I had more. The best way in this scenario, though, is if we look at the blue drops. Okay, at one point, your friend had 3 blue drops, and I had 3 blue drops. So if we compare that, we can actually look at the exact amount of red. So when I put in 3 drops of blue, I put in 9. When my friend put in 3, my friend put in 5. So clearly mine is more red. So I would say your frosting is redder. Okay, I'm going to have you work on this one at the bottom here. You make a carbonated beverage by adding 7 fluid ounces of soda water for every 3 fluid ounces of regular water. Your friend uses 11 fluid ounces of soda water for every 4 fluid ounces of regular water. Whose beverage is more carbonated? So we are going to set up tables just like we have above. And when you set up a ratio table, it can just be a T-chart. You don't have to have all the specific boxes. So we're comparing your beverage to your friend's. And what we're looking at is the amount of soda water to the amount of regular water. So I'm just going to call this soda and regular. And then when you make your ratio table, you don't have to have the boxes that are the same size or anything like that. So I'm just going to make a T-chart, and everybody has an ID. So you can always just use your ID as a straight edge. Like this. Okay, then your friend, same thing. We're going to compare the amount of soda water to the amount of regular water. So pause your video, fill in what you know, and see if you can make some comparisons. So here is what we know. These are the 2 ratios. And what we want to do when we make our comparison, we can use the additive structure and keep adding 7, keep adding 3, keep adding 11, keep adding 4. I can also just use multiplicative, and I can see right off the bat that 3 and 4 both have a common multiple of 12. So I can skip ahead to 12, or just think I'd have 3, 6, 9, 12. Over here we would have 8, 12, but again, you'll see we're going to hit 12. Okay, so you can keep adding 7 until you get here, and keep adding 11, or we can use that multiplicative structure and think 3 times 4. So I'm going to do 7 times 4. Over here, it would be 4 times 3, so I'm going to do 11 times 3. So when this question is whose beverage is more carbonated, if I look at the amount of soda water, when we both have 12 ounces of regular water, your friend has more. So your friend's beverage is more carbonated.